All right, let's do this. Today, we are tackling two of the scariest sounding words in all of math, variance and standard deviation. But I'm going to make you a promise. By the end of this, not only will it all make perfect sense, you'll actually see how it's kind of cool for figuring out, well, pretty much everything. Let's tame the chaos. Okay, so think about it. How do we actually measure the difference between something that's totally predictable and something that's just pure chaos? Is there like one single number we can use to measure that unpredictability? Well, turns out there is, and it's awesome. I mean, you live this every single day. Think about your Wi-Fi signal. It's usually pretty solid, right? Like 3, maybe 4 bars, super consistent. But then there's your bus. When is it actually going to show up? Could be 2 minutes early, could be 10 minutes late. It's a complete wild guess. See the difference? One's consistent, the other is just all over the place. Or, hey, what about this one? You watch a pro gamer and their score is just always insane. It barely even changes game to game. But my score? One game I'm a legend, the next well, let's just not talk about it. The real difference isn't just our average score, right? It's the consistency. So the big question is, how do we put a number on that consistency, on that spread? Well, we need a couple of heroes to help us out. And today, they are the amazing duo of variance and standard deviation. Let's meet them. All right, first up is variance. The easiest way to think about this one is that it's the total wobble in all your numbers. It's this big picture number that measures the entire spread. It's a little abstract, I know, but trust me, it's the powerhouse behind the whole operation. And then we've got its super friendly, easy to understand sidekick, standard deviation. Now this is the one you're gonna love because it's way more intuitive. All it tells you is, on average, how far away is each step from the middle, from the mean. And you know what they say? It's not your standard boring math concept. It's the standard deviation. Okay, I'm sorry. All right, so how do we actually calculate this stuff? I know it sounds scary, but the logic behind it is actually super simple. I promise. Let's pull back the curtain and see how we actually measure the wobble. No calculators required. Yet. Okay, it's a 4-step process, and it's way easier than it sounds. Step 1, find the mean. The average. You got this. Step 2, figure out how far away each number is from that mean. Step 3, and this is the key move, you square all those distances. Now, why on earth do we do that? Simple. We don't like negativity in our math. We're all about those positive vibes. Squaring just makes every distance a positive number. And finally, step 4. You just find the average of all those new squared distances, and bam! Hello, variance! Okay, deep breaths. You're going to open your textbook and see this thing. It looks like an alien language, right? But seriously, don't freak out. You literally already know what this means. See that weird mu symbol? That's just the mean. X minus mu? That's just the distance from the mean. The little 2? That's the squaring part. See? You get it. It's the exact same steps we just talked about, but dressed up in a scary math costume. Okay, enough with the theory. Let's actually use this stuff. We're going to put our spread masters to the test with some raffles and a little bit of risk. So here's our challenge. Which of these raffles is the bigger gamble? And really, when we say gamble or risk, all we're really talking about is unpredictability, right? A wider spread of what could happen. And guess what? We have the perfect tool to measure exactly that. Okay. Here are our 2 contenders. In this corner, Raffle A, a massive $1,000 prize, but a ton of tickets. And in this corner, Raffle B, smaller prizes, but way fewer tickets and more chances to win something. Just based on your gut, which one feels like the bigger long shot? Let's use math to find out for real. So let's look at Raffle A. You've got a 1 in 1,000 shot at the grand prize, another tiny shot at $500, and a massive 998 chance of winning absolutely nothing. Ouch. Winning this one would be awesome, but yeah, the odds are definitely at a variance with my hopes. Okay, so we do the math, we plug it all into that formula we talked about, and we get a standard deviation of $35.32. Now, right now, that number's kind of meaningless, right? It's just a number. We need something to compare it to. But the key thing to remember is this. A bigger standard deviation means more spread, more wobble, more risk. All right, let's check out Raffle B. Yeah, the top prize isn't as huge, but check out those odds. You've got 4 chances to win something, not just 2. And it's out of a smaller pool of only 600 tickets. It feels a little less risky, doesn't it? And boom, the math proves it. The standard deviation for Raffle B is only $24.77. So since 24 is way smaller than 35, our gut feeling was right. Raffle B is the safer bet. It's more predictable because the possible outcomes are all packed closer together. So here it is, the big takeaway. All you have to remember is this. Lower standard deviation means more predictable. That's it. The numbers are all huddled together, they don't wander off from the average. You could say a low standard deviation means your data points are a pretty tight-knit crew. They're not very deviant at all. Okay, I get it. Raffles are cool, but who cares? Why does this actually matter in real life? Well, you'd be shocked. This idea is hiding in plain sight, everywhere from your test scores to your favorite video games. No, I'm serious. Look at this stuff. Your teacher grading on a curve? Yup, that's standard deviation. Game designers balancing a new character or weapon? They're using standard deviation. Weather forecasts? It's how they tell you how likely it is to actually rain. Sports analysts trying to figure out if an athlete is consistently great or just a one-hit wonder? You guessed it. It is literally everywhere. And this is so important to get. A big or small standard deviation isn't good or bad. It just tells you how predictable something is. That's it. Sometimes you want things to be unpredictable, right? Like a lottery. But other times, like with a surgeon's hands, you want that standard deviation to be as close to zero as humanly possible. It's all about what you're trying to measure. So remember, don't be mean, just find the average. So, there you have it. You are now armed with the mathematical tools to measure chaos itself. Pretty cool, right? So now I want to ask you, what's the most unpredictable, high-variance thing in your world? Is it your Wi-Fi, your grades, the school bus? Now you actually have a way to think about it. Go measure some chaos.